So good evening, everyone. It's a pleasure welcoming you here today. I will just say a few words quickly before giving the floor to Nancy. So I'm Linda Amici. I'm Deputy Attaché for the Office of Science and Technology of the French Embassy in Houston. And yes, we do have a scientific office, as well as a cultural one, which is led by Bettina Gardel and Amandine Castillo. Just briefly, one of our missions is to promote, create, and foster collaborations between French and American researchers, either in the academic or industrial fields, which are specialized in physical sciences. And the missions of the cultural services is to promote the best of the French arts, the literature, the language, the higher education in the United States. And they launched recently the Ville Albertine, which is a program that offers tailor-made residencies for thinkers, creators, but also scientists. And we have Fatoumata Kebe with us today, who is an astrophysicist and is the very first resident at the Ville Albertine in Texas. So our two departments, the scientific one and the cultural one, have collaborated for the first time about 2 months ago to work on the showing the interconnection that exists between the arts and the physics. And we dedicated that event to high-energy particle physics. So we welcomed physicists and artists from both France and the United States who shared their thoughts, their ideas, and their work, and it was a success, to be honest. So after this initial attempt, we decided to dream bigger and organize this in-person event in collaboration with Nancy Littlejohn Fine Art, and so this time is dedicated to one of the most ancient connections that human beings have with their environment, which is the sky and the space. So without further ado, I will give now the floor to Nancy Littlejohn, owner of the gallery, and she will be in charge of presenting and moderating today's event. Thank you everyone for attention and enjoy.
Hi everyone. I'm Nancy Littlejohn with Nancy Littlejohn Fine Art in Houston, Texas. We're thrilled to have you here today. This is our first event in partnership with the French Embassy in art around arts and physics. I would like to take a moment to thank our sponsors who made this event possible, the Audi International School, Nancy Littlejohn Fine Art, Marcel Arnaud, and Belgium Reliable Supply. Tonight we will have presentations by NLFA artist Kysa Johnson and astrophysicist Fatoumata Kebe. That will be followed by a discussion and open Q&A. Art and physics are much more intertwined than commonly thought. Art can interpret and communicate scientific knowledge, and scientific breakthroughs require creativity. Art is all about organization, or organized perception, and physics interprets the visible world and the invisible world beyond the senses. Both artists and physicists explore the unknown and shape it with their visionary and revolutionary perceptions. With that, I would like to present our first keynote speaker, Kysa Johnson. I'm going to read a little snippet from her bio. So Kysa Johnson's drawings, paintings, and installations explore patterns in nature that exist at the extremes of scale, using the shapes of subatomic decay patterns, maps of the universe, or other molecular structure pollutants, or of diseases and cures. In short, microscopic or macroscopic landscapes. It depicts a physical reality that is invisible to the naked eye. Often, these micropatterns are built up to form compositions that relate to them conceptually. She looks to scientific imagery to help us understand our place in the complex and beautiful physical universe. Recent work uses subatomic decay patterns as a lexicon to build up compositions based on Hubble Space Telescope photographs of the life cycle of stars, combining cycles of generation and transformation at the very smallest and largest boundaries of our physical reality. So I'm going to turn it over to Kysa, and then
hi, everyone. Thank you for coming. I'm very happy to be speaking today. I'm also very nervous, so
she's an amazing
bear with
speaker.
me. I'm going to give a brief overview of how I came to use micro and macroscopic imagery from science and nature in my work, specifically imagery that I use that is drawn from subatomic decay patterns and cosmology. I am constantly wondering, where did we come from? How do we fit into this grand cosmic scheme from the smallest to the largest? And how can we better understand ourselves and our place in the universe by seeing the patterns in which we exist? These questions are foundational to my work as an artist. I had always been very curious about the natural world and our relationship to it, but I became really excited by it in high school when I had an amazing AP physics and chemistry teacher, Mr. Francis, and he was able to illuminate the beauty of the natural world and the laws that govern it in a way that filled me with awe and wonder at the elegant universe that we are a part of. So from then on, I had these two parallel interests of art and science, but it wasn't until my final year at art school at the Glasgow School of Art in Scotland that they merged. I was particularly interested in quantum physics at the time and was reading all of these pop science books on it, and I came across images of subatomic decay patterns, which are the signature pathways through time and space that unstable particles travel along as they decay into more stable particles. Anyway, I was mesmerized, especially as a drawing and painting major. I was thinking so much about mark making and drawing as a way to describe the world and to impart knowledge about the world and also express emotion about the world. And here I was looking at these marks that were real and thought, oh my God, at a fundamental level, the universe is drawing, like way better than I can draw. So I became obsessed with these marks because they were so incredibly beautiful and began drawing them over and over again. This is pages from my sketchbook from my final year that year. And I would draw them over and over again. And for me, the act of drawing was a way for me to contemplate and try to understand these processes and patterns that underlay our physical reality and also commune with them. And so they became an alphabet for me to make drawings and paintings in the hopes that I could impart this beauty and excitement that I felt with others. So they became my lexicon. I had 11 of these marks that I kind of memorized. And I would start drawing them over and over again, starting large across my panels, and then as lines would start to intersect, areas of mass would start to emerge, and it would sort of, through a conversation with me in it, form the end composition. And I was really interested in hopefully showing like the speed of the mark, but then also that it was congealing into mass, because I was sort of interested in this idea that they were two parts of the same coin and trying to think of a way to maybe express that. And then it was really important for me to keep the notations as a part of the patterns as I was drawing them, because I wanted there to be a clue for people that these marks referred to something real. And that the work could exist on an aesthetic level, but when you looked more closely, you would start to notice these pi's and k's and e's with a negative after them, and know that there was something else going on. And hopefully that would lead you to sort of look further into what that was. And then the title, which is always just what I'm drawing, is another clue that gives you information about the work. And so this is another piece that's just of the particle decay patterns, and this one is chalk and erased chalk on blackboard. And I like using chalk on blackboard as a material because of the reference to the scientific origin of the marks, and also the fact that it's so ephemeral. And I like that correlation between what I'm drawing and then the medium that I'm drawing it with. And there you can see more clearly the sort of marks and the notations. And as I was thinking about this micro-fundamental level, I was also thinking about the other end of scale of the vastness of the universe. And so on the left is another page from my sketchbook from that same year. And you can see at the bottom there's sort of this line with brackets. And I think it's like the distance of the range of the weak force, and then the radius of the observable universe. And I was so curious that we kind of exist pretty close to the middle. And it was a way for me to think about something that I'm always thinking about, is that, like, you know, the two ends of the scale, and then us, and then, like, how does this continuum all relate to each other? And on the right-hand side is a slide. I went to a Zoom talk by the particle physicist Alan Caldwell the other day, and that was one of his first slides. And I was so excited because it for me, represented how I'm constantly trying to think about things. When I work, like, let's skate between these two scales, or try to find commonalities between them. Let's find patterns that connect them, or ideas that connect them. Let's look at the universe and particles. Let's tie in the mid-scale. Let's look at history and geology. And yeah, that excited me. Anyway, so I started looking at image of the larger universe and the cosmos, and thinking about, how do I show these two extremes of scale as part of the same web that we are a part of? And I came across this image of the map of the observable universe, which became the basis for several drawings and paintings. And it kind of felt like this, like, you are here map too, which I liked. And so here is a chalk on blackboard piece based on it. And the masses are composed of subatomic decay formula wrapping around each other. And I wanted to acknowledge that these two extremes are part of the same thing, and even though we haven't yet figured out how to describe that mathematically, and there is no theory of everything yet, we know that they are together, and we're in this thing. And it was also important for me to show the edge, and that there was a boundary to what we know and have observed, and also that there's more to know. And there's a detail where you can see the little formula. And then the next one is using the same map, but it's ink. And these are loops and strings, because I was reading Brian Greene at the time, so I substituted it out. And then after this work, I had several projects that had me investigating the more mid, micro, and macro ranges of, like, molecular structures and microbiology, and using them as alphabets to create compositions referencing art history and history that related to them conceptually. But even then, I was always thinking about them in this context of the different scales, and that they were bracketed by the quantum realm and the cosmological realm. So about 7 years ago, I returned to this idea of exploring the largest and the smallest together. And I had been thinking about particle decay patterns as an expression of these constant cycles of transformation, dissolution, and regeneration that occur in some form at every scale. And having always been in awe of the cosmos as well, I had been reading about cosmological cycles and thinking about the correlation between these two processes. And this spawned the series that I call The Long Goodbye. And this series uses subatomic decay patterns as a lexicon to build up compositions based on Hubble Space Telescope photographs, combining these two cycles of generation and transformation. So here's images of work from that series. And in 2019, I got an email from a French physicist, Urko Reynosa, asking to use one of my paintings for the poster of, for the Conference of French Particle Physicists, and it was maybe the biggest compliment I've ever received. He wrote in the email that he found a mesmerizing representation of the beauty behind the complexity of physical phenomenon, which would fit perfectly the topic of the meeting. And as a non-scientist who is in love with the ideas, processes, and imageries related to science, I never want to tread on territory or do a disservice to the imagery. So this felt like a validation of what I was doing, and he described perfectly what I'm hoping to achieve with my work. So that made my life. So here's that piece, or before was that piece, and then the reference imagery below, and then the poster for the conference. And then after that, some more pieces from that series with the detail afterwards where you can see the particle decay marks more closely and the notations. And then the next one is one of my favorite pieces from this series. And this lives at MIT, which makes me very happy because in the same way, I like when they can live in a space that relates to the imagery that I'm representing. And then after that, I sort of started using that series to look at different elements that we relate to as humans, and like where they come from in the stars. So one of the things that is so amazing to me is how everything comes from the same place. And all the elements that make us and that we interact with come from there. And so I wanted to take this imagery of the cosmos that can seem so far away and abstract and separate, and to try to tie it to things that we can relate to as humans. So for 2 exhibitions, I used different elements that we interact with here on Earth, and that in many ways amplify aspects of our humanity as a conceptual construct to organize the show. And the first one was in Los Angeles and centered around gold. So all of the long goodbye paintings in the show were of areas of space where there are neutron stars and binary neutron stars. And at the time, which was summer of 2017, it was theorized that that's how gold was formed, was the collision of neutron stars, but it hadn't yet been observed. And then it was actually observed while the show was up. I was really, really excited about that. And so, on the floor was an installation of the gold bricks, sort of to, show you that here is the human way we think of this thing. And then on the walls were these long goodbyes of the, areas of cosmos, binary neutron stars. Here's where they come from. And then on the wall was a chalk drawing of the 2 pillars of Solomon, which comes from ideas in alchemy, that this is how you were supposed to enter through them when you began to try to turn lead into gold. So I wanted to take this sort of human story about gold and then put it over the actuality, the real story of gold. And then the second time that I did that was here. Oh, here's another piece from the history of gold, and I think 2 more after that. That one's my favorite. And then the second time I did that was here, where I looked at oil. And so the 4 pieces behind are of nebula, where hydrocarbons are made. And that is where we get the energy that we break apart to get, the energy from oil. And I was particularly interested in oil and gold because I feel like they are sort of neutral substances on their own, but then through our interaction with them, they highlight the best and worst of us. So gold, can be greed and war and, scarcity, greed, I guess, but then also beauty and purity. And then oil, there was so much innovation that came with oil and all of these things, and then also this destruction and war. And so I'm just always curious about how sort of our interaction with nature is what amplifies who we are as people in the best and worst ways. And that also, we can tie it all back to this grand thing that we're all a part of. Is that everything I had to say? I think that it is. So if you go see the show that I have here afterwards, I have gone back to this sort of middle micro-macro realm of history. I think the past 2 years made everything feel very small. But again, the foundational parts of my work are really about the largest and the smallest, and that's a constant. So thank you very much.
So I would like to introduce Fatoumata, but first I would like to make an observation. It's so nice to see these 2 brilliant minds sitting together, because I could tell as Kysa was talking, from my angle, I could see Fatoumata really start to sparkle at times. It's almost like she was saying, this girl is speaking my language, right? And this is the way she is, producing all of these beautiful images of science. It's really quite extraordinary. So I love having these brilliant women sitting with us tonight. It's really quite powerful. So let me introduce Fatoumata Kebe, who is a doctor of astronomy from the Sorbonne University. Her research work focuses on the impact of space activities on astronomical observations, and how such activities contribute to pollution and the earth. She is the founder of Ephemerides organization, which promotes the practice and teaching of astronomy among the public. She is also working on Connected Eco, an entrepreneurial project for water preservation in the farming sector. She designed solar-powered sensors that monitor the drought level of soil and send information by SMS to farmers. The project won an International Telecommunication Union Young Innovators Challenge. She was awarded a United Nations Alliance of Civilizations Fellowship as well. Fatoumata is also a resident of Villa Albertine, a new residency program launched by the Cultural Services of the French Embassy in the US this fall. She just got back from a 5-week residency in Marfa after a first week spent early November in Houston, during which she studied moon rocks and their history. So I'm really so thrilled to have you here.
Thank you.
And please share with us.
Okay, so hello and thank you for being here. So thank you again to the French Consulate for taking me to Texas. I mean, like in a big city like Houston and a small city like Marfa. So here's some pictures I took while I was in Marfa. So I was used to take my car and go driving alone to Big Bend National Park, to Fort Davis, to the Observatory of McDonald's. And so, I mean, when I see these pictures, I'm like, oh yes, this is what I did a PhD, because I'm not used to see some stars in the sky. And also, I don't have so much pictures of the night skies, because in Marfa you have animals. And in fact, while I took this, yoga picture just before, in fact, I started to hear some noises. and when I saw eyes, it was not a human. But I had the time to take some pictures. So yeah, and I mean, for me it was so fascinating because I was like, this is why I did all of these studies, and it's my topic of research, but I don't get to see so many times a starry sky. What happened? So thank you again to the French Consulate, because I mean, for me it was like a reminder of what I'm doing, all of the things I'm doing nowadays. And also, I mean, so now there are many organizations that are working to preserve the dark sky, and first of all, it's beautiful, and also it's part of our heritage, because we are made of stardust. Almost 97% of the elements that we have in our bodies come from space. Cosmic rays, from the death of some stars. So not being able to look at the sky to see the stars, it's like being cut of a part of our heritage. And that's funny, because nowadays my main topic of research is about pollution in space. Like, you know, I'm working to make you see a starry sky, but for that you have to go to Marfa, like me. So let's go back in 1957, so on the 4th of October. So this is a picture of Sputnik 1, which is the first artificial satellite. So as you may know, nowadays we have satellites and everything because thanks to, it depends, of the Cold War. So the launch of Sputnik 1 was the first victory of the Soviet Union, against the American. Sorry for you, but at least you won with the Apollo mission, so that's okay. So Sputnik 1 stayed in space for almost 90 days, and it worked for 21 days, and the rest of the time it was useless. So Sputnik 1 was the first artificial satellite, but also it was the first space debris. And next slide. So since 1957, we have launched like almost 12,000 satellites. We had like 6,000 launches. Nowadays, we have almost 7,000 satellites, and we have like 70% that are still functioning. And so you can see from time to time a decrease in the number of space debris, and it's because some space debris went back on Earth, but still now it's like you have like an increase in the number of space debris. Next slide, please. And so the next image, it's don't be scared. The dots are big, but just to show you where are the space debris, because we know that in space, I mean, we won't be able to see the dots. So it shows you the distribution of the space debris around the Earth. So this is the regions around the Earth that are the most used by people. And so as of November 2021, the estimations were that we have like 500 space debris with a size larger than 10 centimeter, 1 million with a size between 1 to 10 centimeter, and 300 million with a size between 1 millimeter to 1 centimeter. And next slide. So here's a video of a real collision that happened in 2009 on the 10th of February. It was between Iridium 33, a US satellite that was functional, and with Cosmos 2251, a Russian satellite that has been launched in 1993. It stopped functioning in 1995, and so 14 years later, so it was a space debris, they both collide. 2,000 space debris were generated by this collision, but 2,000 space debris that we could track from Earth, which means that there are more debris that have been generated that we could not see. And this collision happened at an altitude of 780 kilometers. And the space debris generated by this collision should stay in space for almost 20 to 30 years. And what we know is that this space debris can collide with other space objects that will create new debris, and this new debris can collide again with some other object, and etc., etc., etc. That's why today, if even we stop to launch anything in space, the number of space debris will continue to grow just because of this chain reaction. And the fragmentation, so collisions and explosions we can have in space, are the main source of creation of space debris nowadays. Next slide, please. So this is our Earth, but also the atmosphere. So this thin layer that protects us from many things. And so when an object wants to come to Earth, it has to pass through the atmosphere. And the atmosphere is like, no way. I mean, it depends on the conditions of re-entry. So the atmosphere burns most of the objects, natural, like the meteorites, and also artificial, like the satellites. But the thing is that the artificial objects are made of aluminum and other components that are not good to our atmosphere. So that's why now there's like a kind of new topic of research, which is the impact of the space activities on the atmosphere. And so an object may be completely destroyed by the atmosphere, but it can be partially destroyed by the atmosphere. So sometimes some space debris will succeed, come back on Earth, but they will like land in the sea. So in the Pacific Ocean, you have like a spacecraft cemetery, graveyard, far from anything, everything. But sometimes, next slide, some space debris can come back on Earth. So this is a US piece of rocket, Delta One second stage. So it was launched in 1975. So right after the launch, it was kind of useless object, and it went back on Earth in 2013. So 38 years later, in Zimbabwe. So it's southern African country. No victims. I mean, it landed far from everything, so that's a good thing. But still, I mean, just imagine seeing that piece of object coming back in your garden. Okay. And so What can we do about space debris? First of all, we need money, but we don't have for now, because it's highly costly to remove a satellite, a space debris, because a space debris, by definition, we cannot control it. So you have to find a way to take it properly and to be sure that you won't create new space debris while doing that. So we have several sub-regions around the Earth, and we have the low Earth orbit, which is below 2,000 kilometers. And for the space debris that are in this region, what we do is, the idea is you take the debris, then you change its motion to make it re-enter on Earth. So, I'm sorry for the atmosphere. But at the same time, we will decrease the risk of collisions between satellites in this region. So this technique has been proposed by Christophe Bonal from the French Space Agency, which is like to generate some dust that will modify the motion of the space debris and make it come back on Earth, or make it move toward a region where it will not impact another space asset. Next slide. So let's take the time to look at a movie. Guess which one? If I say space debris. Do you have an idea of the movie we're going to watch? Gravity. Which one? Gravity. Yeah, Gravity. So unfortunately, I was not invited to play in the movie, but that's okay.
Beautiful, don't you think?
Yes, it's beautiful, George.
The sunrise. Terrific.
Explorer, this is Houston.
Go ahead, Houston.
Mission abort. Repeat. Mission abort.
Explorer, this is Kowalski confirming visual contact with debris. Debris is from a BSC sat. Repeat.
I have Dr. Stone requesting faster transport.
We have to go, go,
Give
go!
any reports meteorological conditions. Don't go.
Houston, Explorer, copy.
Explorer, Dr. Stone requesting faster transport to Bay Area. Explorer, do you copy?
Explorer, permission to retrieve Dr. Stone.
Your cell phone. Houston, Explorer, copy.
All right.
We lost Houston. We lost Houston.
Look, we need to get the hell out of here. Some help there, man? No, don't wait for us. Man down! Man down! Explorer's been hit.
So the movie lasts 1 hour and 31 minutes. To tell you the truth, if I was in the movie, 5 minutes, everything is resolved. But since I'm not in the movie, we are going to see what is the impact of a space debris. So a space debris is made mainly of aluminium and other materials, and what we have done is that a space debris has a size around 7-8 kilometers per second. So that's, it's a high velocity, but what we have done is that we have calculated the kinetic energy of a space debris. So the kinetic energy is the energy linked to the velocity of an object. The higher you have velocity, the higher will be your kinetic energy. So, next slide. If we take a space debris which has the size of 1 centimeter, and 1 centimeter is the size of a blueberry, it's similar to an anvil with a mass of 50 kilograms falling at a velocity of 53 meters per second. That's why you need experts. That's why I was supposed to be in the movie. 5 centimeters. So it's a plume, and then, so this is a French bus. So it's like a bus going to you at a bus with a mass of 11 tons with a velocity of 39 meters per second. So if it's 10 centimeters, You will see, it's a softball, so I think in the US you are used to see that. You won't have the same view if you think about space debris.
Right.
So, so this has been done by my colleagues working at Aerospace Corporation, a US company. I don't have the velocity and the mass of a bomb, because they told us that it's compared to a large bomb. I don't know what it means, but I was like, you know what? 1 centimeter, 5 centimeters, I've seen what it does. Don't need to go to 10 centimeters. I've understood the danger of space debris. So this is all for me, and I hope that you have understand and learned some things about space debris.
Well, this is just so fascinating to hear, and we're going to do a little Q&A. I'm going to go through some questions, and then at the end, if you all have anything you would like to ask, we'll open up the floor. So the first question that I have for Kysa and Fatoumata is, I would love to hear about the similarities and differences you both find in art and physics. Does anyone, who wants to start? Jump in, Kysa. Jump in.
I think they're both a way of organizing perception and a way for us to process the world and the information. And then I think they sort of come out in two very different ways. There's this idea of mythos and logos, and like these are the two ways that humans sort of experience the world. And I guess that I would say like the science, physics is the logos and like art is the mythos, and you can deal with the same subject matter, and then they sort of like express them in different ways. And one is like a softer, like abstract thing, and then one is actually making stuff happen, like saving us from space debris.
Saving us from blueberries falling at.
Exactly.
Right. So tell me what you think.
Yeah, I have to say that maybe I'm also a bit conceptual, because I put some Burberrys in my presentation.
Yeah.
Right, exactly.
Totally.
Exactly. Yes.
Definitely functions as like art in its own way.
Yeah, just that we can work on the same topic, but the outcomes won't be the same for sure. But still, it's interesting because I'm still looking at that, and I'm like, all the equations I learned. So this is where she put it. I mean, it's like fascinating to see how you transform like my knowledge. So,
Yeah, right.
Yeah, it's fascinating. I mean, for me, it's another world, because even when I went to Marfa and exchanged with some artists, I was like, so both of us are humans, but he doesn't see the world like I see it, and it's fascinating. I don't know. It's it's another world for me. I mean, they see things that I don't, so I'm like, okay.
But then you see things that we don't, right? And
well,
so, like,
you can see space debris. If you come to Paris, I can show you some. But
okay, yes, please. But then I think that that's like scientists have that insight to the actuality of something, and that's amazing. And and can provide that information that then can allow people to understand the world in a different way. And I guess I'm so impressed with that, and that makes me want to take what little I understand of that information, but that I know that it represents these grand, beautiful things, and try to impart that excitement so that maybe people will then, go to your research and be like, oh my God, this is amazing.
So let's talk about process. I really love the work process. So Fatoumata, why don't you share a little bit with us about your work process, and then we'll ask Kysa the same.
Yes, so in fact, so it was like logic. So I'm going to Houston. For me, Houston and Texas is linked to the Apollo missions. So many things have been said about the Apollo missions. What are the things I would like to share with the public? And I was like, okay, 382 kilograms of moon rocks have been brought back on Earth from all of the Apollo missions. And I want to know where they are, what NASA is doing with these rocks, and also all the people that are working with these rocks. So I met mainly with scientists, and thank you to the Lunar Planetary Institute and NASA for welcoming me here in Houston. And Marfa, I mean, first of all, I didn't choose to go to Marfa. You have to talk with Bettina here. So, I mean, the French consulate told me, during your stay in the US, you will go to Marfa.
Amazing.
I did not say amazing when they told me that, but I was like, okay, strange, but I mean, why not? Why not? And that was very interesting because I got to learn many things. So again, the world of the artist, and also like to reconnect with the nature, and also, I mean, many things, because I learned that in fact, Neil Armstrong and Buzz Aldrin, they went to Big Bend National Park to do some geology training, but Neil Armstrong signed a book at the Marfa Library, and even the library didn't know about that. They learned it like 4 years ago. Yeah, someone went to the library and said, "Hey, Neil Armstrong signed your book."
That's amazing.
Yeah, and I mean, just for the discoveries, I was amazed. Maybe Bettina, you knew about this book? It was a surprise.
No, I didn't hear before you went.
Okay. Maybe she was like, but let's see if Fatoumata is doing properly her investigations. So yeah, I mean, and also again to reconnect with the dark sky. Because yeah, in fact, I was supposed to stay in for me, I was going to stay in the big cities. And in fact, I mean, yeah, I get to look again at the sky. And for that, I mean, it was just beautiful to be there.
I'm so glad. Well, being in Texas, you can see a lot of sky. And then going out to West Texas is really magical. Absolutely magical.
Just be careful of the coyotes.
Definitely.
And the snakes.
It's real.
Yeah.
It's real.
I know, I've seen that. I've seen these animals. That's it.
So, Kysa, tell us a little bit about your process.
I guess it starts with a niggling question or curiosity about something. Like with the oil, I used to go to my framer and I would drive by these oil wells that still exist in Los Angeles, which is so super weird to me. And that got me thinking about, like, where does it come from? And so then that starts me on researching and looking for imagery, and almost like I'm writing a paper. And then once I've found the imagery that relates to it, that's like, it's, the natural imagery. So I was looking at nebula, but then I was also looking at phytoplankton and fossilized phytoplankton. And then I sort of memorize these shapes and I draw them over and over again until I know them in my body. And then I start drawing them. And then I make paintings. So and for each sort of series, it starts with that. Like there's a question about an idea, or, I think there's a correlation between things maybe, and then I just start researching and go from there.
Amazing. So what inspires you?
Here in the US? Oh.
In life.
Yeah.
In fact, there are so many things, so many people. I mean, I don't know if I could give some names, but there are so many people. I mean, because for example, I would say Christine Chopla, who is in charge of the outreach department, at the Lunar Planetary Institute. Mm-hmm. And the thing is that for me, you must have a lot of empathy to know how to transfer your knowledge, how to make people understand some complicated things. And to see those people dedicating their time to do that, I'm like, wow. For me, just, amazing. And also, I met with Mike Jamison last week. So it's the first Afro-American woman who went to space. And, she's humble and she said, no, I just went to space. I'm still on Earth. No.
Right.
You went to space. And you got selected by NASA as an astronaut. Only 600 people went to space. So for me, it's just wow. And to be able to meet with those people, I'm like just amazed also. But maybe I would say that first position, the dark sky. Yeah. The dark sky. Yeah.
Okay, Kysa, what inspires you?
It could be anything, depending on the moment. I just constantly nature and history, like those are the two things that I keep. Perspective, like I'm constantly trying to understand how to have a greater perspective about our place in the physical universe and then our place as humans in history. So I'm constantly looking for knowledge from those things as a way to, I guess, understand how and why we exist and where in time and space, and then how to maybe relate some small part of that to other people. I mean, it's really selfish interest, but yeah, I think that. And then I guess, yeah, I don't know what else to say. There's so many things I don't even know how to.
So I'm going to skip around on some of these questions because you've already answered quite a few. Have you ever collaborated with an artist before? Is this going to be maybe your first entree to sitting with an artist who does something similar but different?
I did not.
No, you have not. Okay. Have any forms of art inspired or influenced your field of research? Doesn't have to.
No, you can say no.
You can say no. Or you could say Van Gogh's Starry Night and say that's what started it all. Okay, can you tell us a little bit about your background and some of your engagements and what brought you to Houston to be a part of Villa Albertine?
Okay, so I was invited, in fact, by the French consulate embassy in the US to join the Villa Albertine, and for me it was a good occasion to work on the topic related to the moon, because I wrote 2 books about the moon, and also because it's a new experience and I'm like open to that kind of experience. And so in terms of background, I did a master's degree in fluid mechanics. I did a bachelor degree in mechanical engineering, and I did a PhD in astronomy. Science.
Right.
So, and what I like is to transfer my knowledge, and also because where I used to live when I was a child, I mean, there was nothing to learn about space, about astronomy, and I was like, now that I'm an adult, I want the younger generations to be able to learn about space and astronomy where I used to live. Like, it's for me like a way to give back to my society. And for my small enterprise, which is based in France but operates in West Africa, so it's because, I mean, it's also linked to my parents, so they come from Mali, a West African country, and again it was a way for me to give back because I had the chance to do studies and to learn many things, and I was like, I want to do something concrete with all the things I have learned. And I think it's maybe a reason why, even if I'm in astronomy, I went to a concrete topic, which is space debris. But now that for me now it's so much concrete that I decided to do a bit more astronomy. So now I'm studying planetary nebula.
Oh.
Yeah, I know.
That's
It's,
so
yeah,
cool.
so beautiful.
Yeah, it's so cool.
Yeah, because I was like, too many concrete things, and space debris. I didn't say it in the presentation, but you have legal aspect, you have politics, you have military, you have people, too much people. So I'm like, let's go back to like a place where it's quiet. There are not all of these things. There are no anti-satellite tests, because I mean, when you see all of these things, it's like you're like, I mean, I'm looking at the future and I'm like, things going better. And I was like, yeah, but maybe because I'm doing too much complete things. So let's go back to space from Earth.
Beautiful. Okay, so I'd like to open up the floor. Does anyone have any questions for these brilliant ladies? Yes? Please do.
Let me say, as a physicist, I love seeing a Feynman diagram in your sketchbook.
Oh, that's so great.
Question for the ejection of particles to knock down the space junk. How big are the particles, and aren't you just creating more space junk?
How much?
You were talking about the theory of shooting particles, small particles, to knock down space debris.
Yeah.
What are these particles, and aren't you just creating more space junk by?
No, it's not. It's like, I mean, it's a specific type of dust that can be compared to the artificial space debris.
Gotcha.
For example, there are small pieces of space debris that come from the surface of satellites. It's because of the solar pressure. You know, it's like tiny flakes that leave the surface of the satellite, and it is small. It is a small piece of space debris. But the one that Space Blower is working on has nothing to do with artificial objects. It's something that's natural, so no risk to generate more space debris.
Great. Anyone else?
I have a question for Kysa. When you're working on these drawings that are, you're primarily thinking of subatomic particle paths, what leads you to pick the colors and values? Like, do you have in your mind a certain color assigned to a certain subatomic?
No, everyone asked that. Well, the ones that then build up to form the cosmological imagery, I'm using the colors that I'm looking at from the Hubble Space Telescope photographs, so that's my reference, like I'm just relying on that. And I'm using the particles, like the patterns, so there's the 11 patterns that I kind of like have memorized, and I'm treating them like an alphabet in the sense that I have decided it's okay for me to make them really long and skinny or short and fat or twist a little bit, as long as the fundamental relationships stay the same. So in the same way that you can have an A, and you can have a short A or a tall A, but you still know it's an A, that's the boundary that I created for myself, that I'm allowed to sort of like manipulate it within that, to that degree. So that's why some of them will be a little bit more loopy or a little bit longer. Excuse me. So the way that I'm using them more is for their form. So I know there's certain ones that are really good at making like rotund shapes because there's a big like loop in it, and then there's a few that are good for straight lines, but not that many. And so like they get used in certain ways. And then when I was doing the ones that were just the particle decay patterns, the ink on white ones, I was using spectral colors, and I was doing it in a pattern that was not in the spectral light order. I can't remember why I came up with the order. So this is when it gets weird and art schooly. It was like blue, yellow, orange, red, purple, yellow, and that I was kind of thinking about like the idea of breaking something apart to see more, and like breaking apart spectral light to like give us more information. So it was more of this sort of soft metaphorical reason for using those colors. But no, it's fun, but that is, everyone asked me that question. So I clearly should have done that. I totally did.
Great. Anyone else?
I have a question. So this is for both of y'all. Kysa, I know you mentioned that your interest was sparked a little by fine grain. For both of y'all, where does your interest in astronomy and in the cosmos come from? As far as like what or who, as far as the work?
Do you want to go first?
No, I just want to say that for astronomy, you just have to look at the sky. I mean, if you don't fall in love with that, I don't know what we can do for you.
I guess I have a similar answer. It was something, I was always like a sky gazer, like what's out there, what's there, and drawing it as a child. I grew up in a really sort of intense fundamental religion that I left at the same time that I was in physics class with Mr. Francis. And it was the first time that I felt the way that I was supposed to feel when I went to church for like 4 hours every Sunday. And that really, like, I think what happened for me was like, oh my God, everything just is magic. Like, you don't have to sort of like make up all this stuff. It's like, there is so much incredible just around us here. It really just made me want to know more. So cool. Please.
This is for Fatoumata. is there an opportunity for the space industry to create degradable space vehicles or materials? Because one of the conversations we have, for example, in Texas, we have Teslas. You know, Elon Musk is firing rockets into space, and we praise his environmental, with his progress with creating electric cars, but he's creating far more environmental damage with his space exploration project. Just with every launch is far more damaging than any savings from his vehicles. And I'm curious, as somebody who's looking at space debris, what you would say to the industry overall as far as their environmental responsibility going forward in the future.
Yeah, so there are some companies that are working on new type of structure for the satellites. I know that Japan is working on satellites make with wood. So let's see if it's going to work. I don't know. But for SpaceX, it's complicated because there are many questions. Like with one launch, you have 60 satellites that are going in space. And the thing is that not even SpaceX, but once your satellite or space object is useless, just bring it back to Earth. Find a solution. In Europe, we have a law that says that within 25 years after the end of the mission of your space object, it has to come back on Earth. But 25 years, knowing that nowadays we have not only the US, Russia, and China doing space activities, we have India, we have Argentina, we have so many countries. And so once someone told me, yeah, but space is big. Yes, space is big, but the space we are using for the satellites is not that big. So we have to learn to share it all together, and we should agree on how to behave in space. And that's the reason why I'm a bit against the plan B to move to another planet, because I'm like, we have, our planet, we have done some bad things, around the Earth, bad things, and you're telling me that once you will go to Mars or I don't know which other place you're going to act properly? No. So I think we have to work on an international legal frame to protect everything, every place.
Space diplomacy.
Exactly. But it takes a while because, if you look at some text that you have at the United Nations for the Outer Space Affairs, which is based in Vienna, so it says in one text that the moon and other celestial objects are not, no nations can say that it is the owner of the moon and other celestial objects. Mm-hmm. But a lawyer will tell you, yeah, it's written nations, not private industry. Mm-hmm. So that's why today you can find some companies that sell some part of the moon. They say, you can pay to have a star named after you or someone else. Don't do that. It's not recognized. If you want to waste your money, maybe you can give it to fine art. But yeah, again, the main question is, it's not it's complicated to grab a space debris, but the legal frame is much more complicated to set up.
So thank you all so much for coming tonight, and thank you to these two brilliant ladies who were here to enlighten us. And I saw someone out here earlier sort of lip sync. She said, very cool. You guys are just so cool. We appreciate you so much. You're brilliant. Brilliant. Thank you so much. Bravo. Bravo.